I got kicked, so I'm trying to go live now.
Okay.
What happened?
It should be working. Doug, do you see the screen?
Okay.
Doug, do you see it?
Yeah, I see it.
You see my
I see
screen?
it, yes.
Do you see the screen?
Mm-hmm.
Okay.
Yeah, I see it.
Okay, so now it works.
Okay, we're live.
Doug, do you see it?
Yeah, I see it. Yes. You hear me?
Can you mute the stream? You're playing it with the audio on.
Okay. Okay, it's muted.
Okay, I'm just setting up my stuff right now.
But I can't hear you.
But can you hear me?
Yeah. Well, I muted. Okay. Well, You want me to mute my speakers?
No, you need to mute YouTube because I can hear you playing the stream.
Okay. Just a second. Okay.
Okay. Yeah.
Yeah, I can hear you now. Okay, I'm looking for. Okay, YouTube is muted.
Hello?
Can you hear me?
Yes.
Yeah. Can you hear me? Okay.
Yes.
So no more echo, right? Okay. Sorry about that. Okay. Anyway, hello everybody. We're getting our act together. We're glad to have you all with us. This is Doug Solacey. I'm in Loreto, Baja California South, and we're with Vivek Vijay Kumar. He's in San Marcos, San Diego County, California. And now we've got Ross from British Columbia, and Chip from Lynn is there too, and some other people. We got about 23 people out there already. So Vivek's got the setup. He's working the telescope and the camera, and this is a pretty exciting event, and I'm sure everybody's looking forward to it. So we will be watching Jupiter and Saturn very soon.
It's out of focus.
In the meantime, I just wanted to say, if you would like to be in touch with on a regular basis, we have an email list, juliandarkskynetwork@gmail.com. We have a Facebook group, official Julian Dark Sky Network, and the website, juliandarkskynetwork.org, and our YouTube channel, which is Curiosity Peak Observatory. If you become a subscriber to the YouTube channel, you will get a notification whenever we do another virtual star party. And we're planning to do one about, there'll be a solar party, it'll be a star party, but our own nearest star, the sun, will be and that will be interesting because the sun's been very quiet for some time. It's been in a quiet phase without sunspots or flares to speak of, and now things are starting to happen and the sun is getting active again. So that'll be our next event. And if you are a subscriber or on our email list, or part of the YouTube group, the Facebook group, or check the website or subscribe to the YouTube channel, you'll get a notification we haven't scheduled it yet. We're waiting to see what will be the best timing to do it. Figure in weather and also the sun's rotation and the level of activity, but we'll definitely be doing that.
I'm just trying to point the camera right now.
Okay.
So.
Just so everybody knows, this is challenging because, oh, hi Clay, good to see you. That, you know, you have to, where Vivek is setting up, he's got to get to where he can actually point the scope at Jupiter and Saturn, which is close to the western horizon. So from his location, his neighborhood, he's got to go across the street and away from the house and still have Wi-Fi and get set up, and that's all happening before dark. So it's pretty challenging, but no doubt that it will be happening very soon. So right now he's getting pointed at Jupiter and Saturn. And I think the separation is supposed to be about something like 10 arc minutes, I think, or 6 arc minutes. It's pretty close. I don't know what kind of records were kept 800 years ago, but that was the last time that this happened. Okay, so. And we'll also be looking at the moon tonight. The moon's at just at the first quarter, and a lot of detail is going to be visible to us. To just chat with us, even if you want to just say hello, we're here. It's always welcome. We love to know who we're connecting with. Right from Julian.
Well, it's there now, Jupiter.
Okay, well, on Jupiter. Okay.
Now try to find Saturn.
Right. So.
Oh, Saturn's there. Saturn's right there, actually. Never mind.
Okay. One of the most challenging things about imaging the planets is that they're not large objects in terms of their apparent size in the sky, and to see them well, you need good conditions. And because they're pretty low in the sky, it's not the most favorable view of them. Okay.
Should be there. Oh, it is there. Okay, I see it now. The main problem is I don't have tracking yet, so that's the major factor. Okay, let's now trying to focus.
Okay. Yeah, I was just out looking through the telescope outside, and we were actually seeing Jupiter and Saturn before dark. Jupiter, of course, was visible first, the brightest, and then after the sun got a little lower, we see Saturn.
Focus.
Not tracking.
Okay, can you see that, Doug? There it is. That's pretty good.
Yeah, I can see it. It's
All four of the planets.
yeah.
All four of the moons are there. Well, Ganymede's the shadow.
Hmm. Okay, I'm not seeing the moons very well.
Oh, I have to expose it.
Okay, I see Saturn now. Okay, and the lower
Okay,
left corner was okay.
let me.
Yeah, I guess it's not tracking because Jupiter seems to be wandering out of the
Yeah,
field of view.
there's no stars out, so I can't even do an alignment. So I have to manually move the telescope. But it's there now.
Yeah, I'm seeing Jupiter. It's moving. Oh yeah, I'm seeing the cloud bands on Jupiter. So yeah, not bad considering how low in the sky it is.
Yeah, it's pretty low quality, but it's okay. It's expected with how low these planets.
Yeah, okay, and Saturn's visible. Here we go. Okay.
Yeah.
Okay, okay, now I'm seeing Jupiter's moons. And Saturn's a lot brighter.
I have to keep. It's like it's kind of a circus right now. Bringing it back up, then letting it drift, and then coming back up again and again.
Okay, it's not exactly tracking.
Oh, it's there.
I saw it.
Yeah, there was a fireball. Okay, that's interesting. There's a fire.
There's a what?
There's a fireball right near Jupiter and Saturn. Like a fireball meteor.
Oh.
Yeah.
Oh, well, there we go. Now we're getting, okay. Zoomed in.
You want me to zoom in?
Yeah, maybe you could zoom
afterwards.
just to,
It's pretty hard to
Wait,
zoom
wait.
in when it's drifting like this.
yeah,
I can
right.
try my best.
You're using the 12-inch Dobsonian telescope, right?
Yeah, this is a 12-inch, so it's. Let me zoom. Okay, I can zoom in now.
Yeah.
Capturing. Let me try to find Saturn here. Okay, I can't find it. Let me a little.
Okay, yeah, so is there in the image? It's showing.
Well, no, I just zoomed in. There's lag right now. You're seeing the stream, so there's.
Okay,
Okay, there's.
there's a lag in seeing the zoom. Yeah.
Okay, I have Saturn here, but if we just move a little bit over here, you should see Jupiter. Over there. Yeah. Yeah. This auto balance keeps changing. That's better.
Okay, I'd say if you can zoom a little bit more, I wouldn't go, maybe 50% more zoom, you probably still have Saturn and,
Well, I can go for a little bit more, yeah. Yeah. Okay, that didn't work. Okay, I see how the scale works. Okay. That's better. Okay. Let me start another capture.
okay, there's Saturn, yeah, we're seeing Saturn. Yeah, pretty.
What does the live chat say, Doug?
Mm-hmm. Yeah, I think that's more zoom than we need, probably. Especially if we want to see both Saturn and Jupiter, but for everybody watching, you can see those two belts on Jupiter, two large belts. Those are the two main cloud bands. Always there. things about planets. Planets kind of fall into two groups: the rocky planets and the gas giants. And Jupiter and Saturn are gas giants, and they're massive, and they're surrounded by a frozen or liquid methane, ammonia atmosphere, and Jupiter has really, really strong magnetic fields that cause all kinds of interesting patterns. With gassy atmosphere. So those two cloud bands are two of the most obvious features, and of course.
When it gets a little bit darker, I'll probably do a star alignments, because the hand tracking thing's getting a little bit annoying.
Okay.
You can probably tell whenever I try to
do some stacking.
Yeah, once I guess let me see how dark it is right now.
Okay. What okay, for people who are, yeah. Okay, what Vivek's talking is being able to do a little more advanced imaging where images are on the fly, and then you get really more detail. So it's not quite dark, and that's the challenge, is to have the scope be aligned so it can track smoothly, because in order to take multiple images rapidly, capture an image, stack them, it has to stay on the target pretty precisely.
You should be seeing the moons right now. I think Titan's at the bottom left of Saturn, and we've got the three main moons of Jupiter. All of them except Ganymede. Ganymede's right now, it's right now in front of Jupiter.
Oh, don't see the moons. Oh, there's moons. Stop for a second.
Remember, Doug, you're seeing the stream, so it's what I'm quite talking about right now.
Yeah, so lag. Yeah, okay. Well, Jupiter's moons are showing. I'm seeing three, because I think Ganymede is transiting Jupiter, right?
Yes.
Or is that happening later?
No, it's doing that right now.
Okay.
Maybe I'll zoom in so people can see that again.
Ganymede is passing in front of Jupiter.
Yeah, you can barely split Jupiter and Saturn by eye, so that's... What? What did he say, Doug?
Yeah, transits by Jupiter's moons are fairly common,
Yeah.
but nevertheless, there are published calendars that show when the different moons transit in front of Jupiter. In other words, in our line of sight, they actually are, even times. And then the other thing that happens is they go behind Jupiter, and then they're occulted.
Okay. This thing is...
too small to...
I don't know if people can try to see Ganymede.
The seeing isn't good enough?
It's a little bit Ganymede. But it's...
Yeah.
I guess we'll take what we can get.
Yeah, well, Jupiter is pretty overexposed, too, so it's... Okay, the view of Saturn is pretty nice there.
Yeah, but the other problem is you have to properly expose both planets. So, because if I properly expose Saturn, then Jupiter gets blown out. Because Jupiter's the brighter of the two.
Right.
And it's also larger in apparent size.
Well, maybe do them one at a time. You've got Jupiter blown up quite a bit. Is it focused about as good as it can be?
Yeah, the focus is fine. It's just it's very. I think it's probably like 23 degrees right now, so there's not a whole lot to do.
Yeah.
I can see Mars already, so I might try to do a star alignment. So I don't have to keep doing the manual tracking. So let me get that done.
Okay, Chip wants to know where in relation to Jupiter's Ganymede. Well, Ganymede is right in front of Jupiter. If Jupiter were higher in the sky, we'd be able to see it. Actually, it would be, detectable. But because Jupiter's low in the sky, there's a lot of turbulence and thick atmosphere. So anyway, that's kind of it's there. We know it's there. It's just a little bit hard to see it right now. Earlier in the season, Jupiter was higher in the sky, so we could see a lot more detail on Jupiter, as well as moons and their shadows and things like that, which is pretty interesting when you see a shadow of a moon crossing a planet. And it happens because the moons rotate around Jupiter pretty fast. You can actually, from hour to hour, see them moving across in front of Jupiter.
There it is.
To see their position changing even when they're not transiting.
There's Vega. Just make a quick stop to do an alignment.
Okay, all right. Alignment is getting the telescope's mount acquainted with its current position relative to the sky, so that it can actually track automatically and that'll enable us to see some more enhanced views. Telescope mounts need to be trained when they're set up to identify some stars and their positions, and then that gives the mount reference points. That's the bright star Vega in the constellation Lyra, which is part of the summer triangle, which is still visible, although it's passing to the west and will soon be gone. But the summer triangle is a good reference point. Okay, Kathy Hansel is with us. Welcome, Kathy. And appreciate your co-hosting at San Diego.
Okay, alignment's done, so now I can go back to conjunction.
Okay, all right. Well, thank you, Vega, for providing us with a reference point. And we'll get back to
that one was Fomalhaut. I did Vega and Fomalhaut.
All right, we've got that was Fomalhaut?
What?
You said that wasn't Vega?
I did Vega, then I went to Fomalhaut.
Oh. Okay, well, that gives you an extra star to...
I'm going back to Jupiter.
Okay, I know we have... Sorry? Okay, now we're going to go back to Jupiter. Okay, I know we got a bunch of people out there who are watching, so if you want to identify who you are and where you are, that will be of interest to us and to everybody else. And also any questions about the planets, about the current alignment. Why is there a, we're certainly open, doing our very best to answer your questions, and some of you may answer the questions for us, to give us some interesting commentary. Okay, I'll just repeat something I said earlier on. For people who want to be in touch with us for future virtual star parties, or as well as when we get back to doing in-person star parties, please join our Facebook group, which is Official Julian Dark Sky Network. You can go to our website, juliandarkskynetwork.org, for the virtual star parties. You are now watching us on our YouTube channel, Curiosity, and you are welcome to become a subscriber, which costs nothing. And what it does for you, it gives you a notification whenever which vary in topics. You can watch some of them on the channel and see what kind of stuff we do. Sometimes we're looking at galaxies, star clusters, nebulae. We've done a star party about using low price equipment, telescope and camera to do astro imaging for people who want to get started in that, who don't want to spend the thousands of dollars. It's possible to get going with relatively low budget. So check them out and become a subscriber. We'd love to have all of you come. We'll be doing another star party, another virtual star party in the near future with our closest star, the sun, will be the topic, the subject. And why are we going to be looking at the sun? It's because it's starting to get more active and produce sunspots and flares and prominences, and should be very interesting to watch. And we'll be doing that, of course, in the daytime.
Okay, there's your better Jupiter now with tracking, so I don't have to do any more.
Okay. No more tweaking.
Yeah, I'm also gonna set up something else so I can see it.
Okay. Okay, so you're going to use sharp capture to do some on-the-fly stacking?
No, we can't. Nah, for stacking, I can't
Okay,
stack.
Victoria.
SharpCap only does live stacking so for planetary I would use auto stacker, but since this entire field of view is pretty,
okay,
it's gonna take more than this star party will last to stack, so I won't be stacking this time.
Yeah.
But I can post the image later.
Yeah. Okay, Victoria's with us, also from Loreto and down here in Baja South. So, Vivek, you want to say something about what we're seeing on Jupiter? We're starting to get a pretty decent view of it, considering how low it is in the sky.
Okay.
Okay, Betsy Knock from Borrego Springs. Good to have you, Betsy. And also Chris and Janet from Borrego Springs, Donna Turner from San Diego, Julie in Indianapolis. Wow, we've got quite a range of
Okay, this thing's pretty bad right now.
Coming from. Yeah. Okay, and by the way, Betsy's wishing us a happy winter solstice, so that's kind of a coincidence with this conjunction.
Okay. I can actually see the live chat.
So I'll throw out some questions. Yeah.
Oh, no, I don't want that.
Okay.
Well, I guess I'll start another. This thing is kind of bad right now. It's even worse than before, so... Let me look at Jupiter up close. Yeah, so it's... Let me check the focus again. It's also the dusk, so temperature changes are kind of expected.
Okay.
Okay, that's not good. Ugh. This is why people don't like imaging planets usually at 20 degrees. Okay, that's the best I can get. Maybe I'll try for the moons again.
Yeah, well, we can always wait 800 years and see if maybe it'll be higher in the sky next time.
Yeah, it's unfortunate. But it's still getting the sky.
Yeah, well, at least we can see it, you know.
There we see another moon. I think that looks like it could be Enceladus. I'm not sure. I'm pretty sure this is Titan though, because it's the brightest. Okay.
Okay, Vivek, do you know why we're seeing your screen?
What? Can you see the screen?
We're not seeing your screen anymore.
Is it buffering?
I guess it must be, because I'm just not getting anything.
Let me check
It says
YouTube.
an error occurred, please try again later.
That's on your end.
Yeah, we've lost the video.
No, that's on your end. The audio is,
Oh, that's my end? It's,
yeah.
well, I
If
think,
it's error, that's
somebody
not,
else is saying the same thing.
well that's audio.
Yeah,
The audio got lost for a second. I think the video's back. And it did that again. Oh, odd. What happened? You cut out. What is the magic? SNR 0. Should be back soon. It's very low. Oh, it's back. Okay, is it back? Nah. Doug, can you hear me?
movement of Jupiter's moon. Yeah.
Okay. So yeah, I'm outside with the hotspot because I'm not anywhere near my home. So the Wi-Fi is in, but it is what it is.
That's what Tom said.
Okay, let me see if it's back. Okay, it is back. Alright.
Yeah, we're
Huh?
we're getting a really nice Saturn. Okay, now we're seeing Jupiter more. Definitely worth going outside and taking a look too, if you have binoculars or a small telescope. And I've been watching night by night, both just with the naked eye and with the telescope, as the two planets have gotten closer noticeably every night. Can you zoom in a little bit on Jupiter? Or Saturn, there's Saturn, yeah. Okay.
Yeah.
Yeah, now Saturn has one big in between its rings. It has 7 rings, but there's one major division called the Cassini division, and you can kind of see it. It's towards the outer part of
You
the
can see the
ring.
rings on there, huh?
See, it's just like every once in a while.
Yeah, it's live stream.
Oh, that's cool. Yeah, it's right here. You can see it on there. Look, Leo.
In between.
Oh
This is
my
what you can
God.
see from the telescope.
Leo, come see.
Look, Leo. I don't know, on the computer. On the computer. This is what you can see from the
That's
telescope.
what the telescope is seeing.
Yeah.
Isn't that amazing?
Yeah, but where's that free?
Where's the rings?
Yeah.
It was just on there a second ago.
Yeah. Can you see the smaller
It
one
sounds
here?
like you got
You
some
see how
people
there's
from
kind of
the
like
neighborhood.
light
Open it back
coming
on
out
the
a
rings
little
here.
bit? Do you see?
Oh, now I can see the rings on
Do you
there.
see how the out of the circle it's kind of like glowing like that out? Those are the rings.
Isn't that cool?
See the water.
And there, it's
it
right.
right there?
Look, it's right
Out there
there.
and look at it. You can see the rings and the... Wow,
That's
that must be a
incredible.
powerful telescope. That thing's huge.
Yeah, it's a 12-inch.
How many times does it magnify it?
It's a camera, it doesn't magnify.
Oh, okay.
Oh.
That's the camera. That, right.
Gotcha.
It's amazing.
That's amazing.
They
Okay, do people know
so
that
much
this is being
farther apart on
broadcast?
the screen.
I know. On the screen, they look all far
Yes.
apart, huh?
Yeah.
That's pretty cool. Well, thanks for letting us check
thank
it out.
you. All right, Leo. Did you see the rings on it? That's so cool. You're so lucky.
Yeah. Huh.
Okay, Kathy's got
See
her
the stripes on
telescope
like this.
set up and watching and also connecting with us on
Yeah.
our
Well,
channel.
some of the neighbors are here to see the view.
Yeah, I can hear the discussion. You're getting some live chat on the spot. Shelley Krieger is asking, why is it called a conjunction? Oh, Laura Coons from
You
Ramona.
see
Hey,
on the
good to have
planet
you
how there's
back,
kind of
Laura.
darker stripes going across.
That's equatorial belt.
Simply are lined up.
Wow.
In other words, if we're looking at,
Right.
say,
That's cool. Remember when we were
say
looking at
Venus
the
and Mercury, and they're pretty close together, that means it's a conjunction. Because what it really means is that the Earth and the two other objects, whether it's Venus and Mercury, or in this case, Jupiter and Saturn, we're all in a line. We're lined up. Doesn't mean we're lined up with the sun necessarily, but we're in the line with each other. So that means that the orbital positions of each planet kind of coincide. in a certain sense, it's like an eclipse of the sun or moon when you have the moon, the sun, and the earth lined up, and the earth's shadow is, if the moon passes through the earth's shadow, it means it's right directly behind the earth in relation, opposite the sun. If it's a solar eclipse, that's a kind of conjunction too, because that means right in line between the earth and the sun, so precisely that it actually blocks the sun, and we get a total solar eclipse. So I don't know if that helps you understand what a conjunction is. It's just kind of when things are lined up. Okay, now we get a pretty good view of Jupiter and cloud bands.
Yeah.
And is Jupiter really jumping around like that? Is it unstable? No, it's not. That's the Earth's atmosphere. It's just like if you were watching, standing in front of a running stream of water, and there was a fish in the water, and the fish seemed to be wiggling all over the place. It might just be that the movement of the water is, distorting the image that your eye is getting, because it's not a stable medium. And the Earth's atmosphere is often not a very stable medium to observe through. That's why we got telescopes orbiting in space. And this gets, the best viewing is usually when objects are higher in the sky, especially if they're right overhead. That's the best time to view them. But we don't have a choice, because this is a time of year when Jupiter and Saturn are pretty low on the horizon. They've been up much higher through the summer and the fall, but they weren't that close together. So the conjunction is taking place just as they're kind of bowing out from the winter sky. But they're still there in time for us to see this, so can't complain too much. And now you're seeing the moons, okay? Seeing 3 of Jupiter's moons. We have what we call the Galilean moons, the moons that Galileo first discovered when he pointed his primitive telescope up to the sky. And we're seeing a couple of Saturn's moons too, including Titan, which is has its own atmosphere. It's a moon, but it's got an atmosphere, unlike our moon, which has no atmosphere. Okay, now we're starting to get a little, we're getting a good view of Saturn there.
Yeah, it's a little bit blurry though.
Tweak the game a little bit. Huh?
It's getting real low now. It's probably like a few degrees. Let me check how many degrees it is right now.
Yeah, well, for a moment we had a really, really nice view of Saturn.
It's 13 degrees right now. They're both 13 degrees.
13 degrees, okay.
So it's really, really...
Yeah. Yeah, and just for people's reference, 90 degrees would be straight up overhead. Or it would be, I should say, on the meridian. It would be right between
it's
and west
near almost setting.
Yeah, it's almost setting. And most people don't have a horizon that would be 0, so there's usually some buildings or trees that are going to determine how low we can see it. Yeah, so is, I think but Jupiter is lower than Saturn. No, it's not. I guess they're about on level with each other. Yeah, okay. All right. So Laura's with Chloe and Ramona. Okay. Yeah, Jules wants to know how there's almost one planet, the Christmas star. I think with the naked eye, they probably do look like one single bright object.
Yeah, you can split
if you
them.
go outside and you've got it.
They're splittable. You can see them as 2 distinct objects, but they're very close together.
With the naked eye right now, are they still
Yeah.
separate? I'm not outside, so I can't see.
Yeah, they're really close, but you can still see that they're apart.
Yeah, they're still distinct from each other. Yeah, well, they're about a apart, I believe,
Yeah,
which is pretty close, way closer than.
but that's still 6 arc minutes, and we can split things up to around 1 arc minute apart using
With our eyes.
Yeah, so it's just 6 times the distance before you separate it. It also depends on how good your eye is, obviously, too.
Okay. Yeah. Okay. Edward Masterson wants to make a comment about why it's blurry.
Oh yeah, it's because of the atmospheric distortion of being 10 degrees above. So we're seeing through a whole lot of atmosphere.
Yeah.
We're seeing around like 40 times more air mass, the amount of air, than if we look straight up. So lots of air mass. There's a lot of air to look through. So it's going to be quite blurry.
Yeah, if you think of it like if you were below the surface of the ocean and you look straight up at something, you know, that was just above the water, you would have a much easier time seeing it than if it was, say, 100 yards away and you're looking diagonally through the water at a much greater distance, looking through a lot more water. So it's the same thing with the air. That's one reason, like, observatories are up on mountain peaks.
Once it gets a little bit low, I might change.
They're above a lot of the atmosphere.
Once it gets a little bit low, I might just change over to the moon and then we'll end it. Because it's getting very low now.
Okay, yeah, let's head over to the moon.
Yeah,
the moon is a lot higher.
Yeah, the moon is very high, it's very brilliant.
Closer. It's smaller. Yeah, it's way smaller than Jupiter, but it's a lot closer. It's only 240,000 miles away, so we get to see a lot more on the moon than we can see on Jupiter.
Yep. We can see.
And the moon is a great object to watch throughout the month too, even with binoculars or a small telescope, because every night the position the angle that we're seeing the moon from is changing as the moon orbits the Earth. So we see a different area that's illuminated as the moon is, of course, turning, and its own shadow is you know, half of it's dark, but because we see it from different angles and the shadow is moving, that area where the shadow meets the illuminated part of the moon we call the Terminator, and that's where you really see a lot of detail. That's where the craters and the mountains and all those things stand out because they cast shadows. And so, you know, if you have a small telescope or even binoculars and you watch the moon from night to night as it goes through its phases, you see a lot of different features really standing out. Because one of the things about observing things in the sky is contrast is really important. So when we have dark areas next to illuminated areas, we see a lot. Just like when we're in a dark sky up in the mountains or anywhere where you don't have light pollution, the contrast between the dark sky and the object that you're observing makes this stand out, and you see it a lot more, whether it's meteors during a meteor shower or comet or planet or galaxy nebula, which is why we value having a pretty dark sky up in Julian, where we do a lot of our observing and imaging, because we don't have very much light pollution, so we're able to see a lot of things that you can't see in the city. And we're right now in the process of becoming an international dark sky community, which will kind of create a real identity for our community as having that dark sky, and also set an example for other communities to control light pollution and make that sky, you know, what it should be, a real phenomenon that can really, be
Okay.
amazing to be.
Okay, that's the. This is probably this is the last image of the conjunction. I'm gonna move over to the moon now.
Okay. All right. Yeah, that was we just got a little glimpse of Saturn, still looking pretty good. I think we saw the Cassini gap there.
Well, it's overexposed right now. Unless.
And we're certainly seeing
delay.
Jupiter's. Yeah,
Okay.
yeah, but we're seeing the moons.
Okay, I'm moving over to the moon.
Okay. One thing you might want to know too about what we were just doing with Saturn and Jupiter, what the light that is hitting the camera from Saturn took about an hour and a half to get to bounce off the sunlight, to bounce off Saturn and actually get to Earth. And the light that shines from Jupiter, which is reflected sunlight, took 49 minutes and 16 seconds to get to us from Saturn. And that varies throughout the year because both planets are moving around the sun. The Earth is moving around the sun, so the distance between us and any planet is constantly changing. Because we're not standing still. Nothing is. Least of all the planets and objects in our solar system. Yeah, they are the two biggest planets. Now, Jupiter looks a lot bigger, partly because it is bigger, but it's also considerably closer to the sun than Saturn. And that's also in the sky. Many of you get up early in the morning, before sunrise, you'll see Venus, and Venus is really bright. It's brighter than Jupiter, because it's a lot closer and also has a very reflective atmosphere. So sometimes people refer to it as the morning star, but of course it's not really a star, it's a planet. But before people knew there was a difference, they called it the morning star.
Okay, there it is.
Okay, yeah, there's Saturn down there.
Okay.
Okay, I think we just caught up with the fact that the scope moved.
There's the moon. Okay. Let me refocus it now since it's moved.
Okay, yeah, thank you, Kathy, for supplying us some more information. A real concise definition of conjunction. And then great conjunction. Jupiter and
Okay, this
Saturn.
focusing is getting a little difficult.
Okay,
That's
now
the best I can do.
getting some glare.
Okay, Doug, do you see the moon?
I don't know. It's hard to tell what we're looking at. I think we were seeing maybe the limb of the moon.
Okay, so it hasn't this we haven't so the
Okay.
stream hasn't caught up to you yet.
Oh, there we go. Now we're starting to see the Terminator. Okay. And some detail. Yeah. Okay, catching up. All right. Oh, very nice. Yeah. Okay, that's okay. Which mare is that we're looking at?
I don't know what you're referring to. I've already moved on. I'm still
Oh, okay.
focusing there. That's all I was doing. So
Okay.
yeah, you have to remember about the lag. Okay. Okay, I'm right now looking at the Terminator. Albategnius, we've got, and some other craters. This is Theophilus. Okay, so we've got those two, and we've got them centered here. So. They move. Center them. That FOV isn't big enough.
Okay, yeah, nice one. A little color there. Okay, that's very sharp. Okay, so there will be Kathy's saying there will be a Jupiter-Saturn conjunction in year 2080.
Okay, so
probably
just
not as close. Then
so mark your date. Mark the date now.
yeah.
Now's the time.
March 15th, 2018. Well, you'll probably be around.
You can't be too sure about that.
I think you will. Okay, so this one is the closest since 1623 and the closest observable, which I'm not sure. Maybe because of the one in 1623, it might have been lined up with the sun. Because if they're right in front of the sun, then the only way we'd see them as transits across the sun. But you need a solar telescope then to observe the sun and see the well, no, you wouldn't see them like that because they're not inside our field of view. They would be behind the sun if they're not observable. Okay, Kathy's citing Earth Sky website. That's a great website, and Earth Sky, I think it's Earth Sky News, is something you can subscribe to for free or make a donation. It gives you daily updates on what's up in the sky. Really good information, a lot of science, a lot of really interesting stuff. I've been partaking in that one for several years. Earth Sky News, that's what it's called. Okay, yeah, it's pretty sharp. We are, notice how it's shimmered just a little bit, and that's the atmosphere that we're talking about, but
yeah, the smaller scale, the ones where it looks like you're looking
near as
the ones where you're looking through, trying to look through like it's like looking through like water or really hot air, because that is what it is. It's hot air. And we've got this crater here is called Theophilus. You can see these three mountains in the center. That's from the ejecta from when the meteor or asteroid struck the lunar surface, and you get this bounce back from Newton's third law. So that's the crater ejecta at the center of craters. You tend to see this a lot in these craters. And then we've got these two craters that are still, sunrise hasn't occurred there yet. So some parts of these craters are still seeing they're right now experiencing sunrise. So, and this is usually where you get the best contrast of detail. Because if we swing over to away from the Terminator, everything has way less contrast because it's fully illuminated by the sun. So you can't really see a lot of the details because there's no shadows to really show the contrast, except in a few places like some of these craters where they have the crater walls create their shadows. But Yeah, we got some mountains here. These are the Apennines of the moon. We got these two craters here. Let me try to find this. This is the, I think this is the this is the north pole of the moon over here. And you can really see how you can tell that this is the moon is a sphere because these craters are starting to curve away from where we're looking at. So let me swing back here. Trying to find Elpis. Okay, it's over here. It's in the shadows still. There's this little pass here. Let me see if I can increase exposure time. Yeah, this pass over here is called Alpes Monte, and it's in the Apennines. So it's like a little ridge. Oh, if you look over here, you can actually see the shadows from these peaks right here shining across the moon. Can you see that, Doug?
Mm-hmm. Yeah, they're visible.
You can tell these are three-dimensional objects.
Mm-hmm. And which way, can you tell us which way the shadow or the Terminator is moving?
Well, it's moving to the right of the screen because the sun is still rising. Because you can see the sun is shining from the west, or from the left side of here.
Mm-hmm.
The left side of the screen. And we've got these craters. We've got these craters getting illuminated, and you can see the shadows from the peaks as they experience their first light.
Mm-hmm. So how long would we have to wait to really see a detectable change in where the Terminator is?
A few hours. It'll take because this cycle is 29 days long. So the Terminator slowly creeps across the lunar surface. And we can see over here we got some more ridges, and we've got some craters here, and we've got some mountains. There's a lot to see on the lunar surface, so another problem is trying to expose some of these places.
Oh, there we go. Now we're really seeing contrast. Yeah.
And then we've got some.
Yeah. Of course, if we come back tomorrow night and look at the moon, we're going to see some completely different features of the Terminator.
Yeah. Let me get back to those shadows because they look really. Yeah, there we are.
Yeah, that's very, very, very three-dimensional. Yeah.
Yeah, there's a whole lot to see on the lunar surface here.
And some people make a hobby of sketching parts of the moon.
Yeah.
As well as just seeing what the smallest details are able to observe, because it'll vary from night to night. Depending on the atmospheric conditions, and really way.
Because of how the Terminator casts different shadows, some people they take an image of a crater, then they take an image of the crater on a different night where the Terminator is in a slightly different position, and they can create a 3D projection from that.
Mm-hmm.
So you can actually look at the crater as if you were looking at it, like three-dimensionally.
Now the reels, the reel that you just had on the bottom of the screen, that's caused by a meteor kind of skidding along on the surface, or?
Well, I think it's more geological. Like you tend on Earth, and they're formed by rifts and all those sorts of functions. Like lunar geology is too different, except it has an atmosphere that can really stop meteors, while the moon really doesn't have that much of an atmosphere. So you see
no erosion.
And also, yeah, there's erosion on Earth that helps to erode away these craters. But on Moon, the geological processes have almost basically stopped. So anything you do there will remain there for a while. And that's why people say the astronaut's footprint will stay there for a while.
Okay, Lynn's asking, what is the Terminator?
The Terminator is the dividing line between the part of the moon that is in shadow and the part of the moon that is illuminated. So it's where sunrise or sunset is occurring on the moon. So we're right now looking at the Terminator, because we see the side illuminated by the sun and the side not illuminated by the sun. So okay.
Yeah, maybe an analogy would be when, sunrise and sunset, when the shadows of mountains and everything are really long shadows that we see on Earth. That's when we are in the Terminator.
Yeah. Well, Doug, I'm running out of battery on my laptop now, so it's time to start concluding.
Okay. Well, all right. Well, anyway, if anybody has any final remarks they'd like to make, or feel free to post them on our chat. And once again, I encourage everyone to be on our email list, Julian Dark Sky Network at gmail.com. Join our Facebook group, which is official Julian Dark Sky Network. We post both events, but also things that are happening in the sky, things that you can get outside and look up and see at night, whether it's meteor showers, all kinds of things, scientific discoveries that are important about our cosmos. Lynn does a lot of posting of very interesting stuff, does a great job of keeping us glued to the Facebook group. And also you can subscribe to our YouTube channel, and we will be doing a solar star party kind of dedicated to our nearest glorious star, the sun, which makes life possible on our Earth. And it's starting to have some really interesting activity, which we'll highlight when we do that. It'll be on a Saturday during the day. So please join us and email us any comments, suggestions, criticisms are all welcome. We're doing this on a shoestring, so we don't have the a treasure trove of technology, but I think we're doing fairly well considering. So thanks everybody for being with us. This is Doug Solacey, and I've been with Vijay Kumar, and we look forward to seeing you again. So please rejoin us next time. All right, everybody have a great night.
Okay. Good night.